Involves me trying to put cups into a cup. So how many of these cups can I fit in this cup? Okay, and I'm just going to start pushing them down in, and you guys can tell me how many I can get in here. How many do you think I can fit in? One.
It depends. Are you a magician?
Two.
Are you a magician?
Yeah, actually. Okay.
A magician
Three.
of science.
Alright.
I'm a guess.
I just need to push a little. You know, you just push, they just sort of disappear. They go down in.
I'm guessing five.
There's a hole underneath.
How am I? I'll keep the position there. Okay.
There's a hole.
Okay. You think I can get them all in there?
Yeah.
What's going on? How in the world?
Because there's a hole underneath it.
I mean, I'm not pushing real hard. I'm not crunching.
Because you're just bending the tops down, the bottom's just staying. Or you're not
Okay.
squishing it completely.
Or maybe they're magically disappearing.
No.
Going into a black hole that's in the bottom of that coffee cup. I think that's a
hole
You're just
possibility.
bending the tops. And
Which leads to a hole of death.
Yeah.
You think so?
I don't know, can you show us all the inside of it?
You know, a magician never gives away. How many cups just went in that one cup?
Like eight.
Eight cups. All right, where are they?
They're in the
Are they still in here?
Yes.
Are they down here?
Yeah, I don't think so.
You don't think? All right. Well, you want to see inside?
Yeah.
See it's empty?
No, keep going.
Nothing there.
How'd you do that?
No, I can't see you.
What? What?
Not really empty. There it is.
Oh, it's wet. Duh.
8 cups. What do you think happened?
What is it?
Acid or something.
There they are. 8 cups.
Did you heat the cup?
No, you put something in
There's
it
like
and
acid
then
or something.
It's a magic cup. Try it at home. Take any coffee cup and just start shoving.
I want whatever you put in there. Can you give it to us?
No, you can get it at home.
Thank you, sir.
Nope.
Vinegar.
Nope. Nope.
Salt.
Nope. Keep guessing. Some of you use it regularly, almost every day.
Soap.
Probably more the girls do.
Soap.
Probably.
Shampoo.
Makeup.
I hope the girls don't use soap.
Yeah, they do pretty much. No.
Nail polish.
Acetone, nail polish.
Oh.
What it does is it breaks down this is called polystyrene, styrofoam. But when they make the styrofoam cups, they blow a gas into it and expand the polystyrene. It's called, in technical terms, those aren't called styrofoam cups, they're called expanded polystyrene cups. Okay. Yeah, try that out.
Expanded
How
polystyrene cups that I can...
the team does to you. But anyway, expanded polystyrene. This lets all that gases out, and this will turn into a hard, brittle thing. Now, I bet you've seen the cups that are clear, but they're brittle. If you squeeze them, they'll snap. That's just regular polystyrene. It says on the bottom PS. It's like number 6 in recycling things. You guys ever looked at the bottom of recycling things?
Yeah.
And there's a one through like, I think it goes to like 7. Number 1 is, you guys probably don't know any of these.
I do.
Yeah, in some places they've expanded that to more. Now I think they take everything. But number 1 is soda bottles. Okay, number 2 is usually like milk cartons. And then it goes down. This is number 6, and this will get hard, and this will be brittle. We can snap it. But right now, it's still a little soft.
Ew, looks like
That's cool.
Mr. Williams.
What's it look like?
Play-Doh.
Yeah.
Yeah, it's not even fun with it. You should sell that, Mr. Williams. We can make tons of money.
Why would we? Why?
Kids would love it. Give it to them little like 5-year-olds.
Yeah, well, I'm not sure the kids, this is something kids should be.
Dude, you should make a magic kit and sell it. Like,
I'll try to press it
you
out.
can make a YouTube video and then everyone will want it.
This is really cool with packing peanuts too, because you can take a bag of packing peanuts and just say, how many of these do you think I can fit in that cup? I mean, just like 50, 100, 200, 300. It's like no limit. See.
Dude, what if you had a pocket that was kind of like that?
I want to see
had, like, a
some-
frame
Yeah.
in it, and then you had some of that in.
Throw a rabbit in the cup.
You know what would be a real good trick? If you could turn it back into the siren.
Put a rabbit in your cup.
Yeah, I can't do it. It's special machinery.
That's magic right there. You throw a rabbit in there.
Just talk with the rep. I'm not a trained magician. All I know is a few chemistry tricks.
Yeah, rather that.
You gotta have a rabbit trick magicians when you get it. Okay. Anyway, all right. So there was our little. We could try another one here.
Yes, we do.
We got plenty of time.
You asked if I could do it. Your job.
Grade me.
I want you to see if you can get the maximum number of punchies out of this. To punch it and save it, because they're part of the demo. Okay, so see, strategically punch the maximum number of little punch holes out. I'll give you a little beaker to put them in. And we'll go back here as soon as you're done.
Don't do it over
Put it over
the...
your desk.
You gotta save them. So go ahead, start punching. Start punching. I'm not wasting it.
I feel like the guy from the Polar Express.
What Seth has,
It says believe.
Seth has a 3x5 card, half of one, and I scribbled graphite from the lead from the pencil, graphite, on one side, and let the other side just like okay? Alright, so here's some water, just regular water. And I already told you what I did. What I made was I just took a 3x5 card and just scribbled it up with graphite on one side, left the other side paper.
I bet they all
So-
flip and go.
Well, here's the thing, yeah. First of all, we're going to pour, this one I keep my fingers crossed on. I'm just going to pour these in, like in a random way, onto that water. And what would you expect the ratio of ups to downs to be?
50-50.
About, okay, well, yeah, and, randomly selected. I'd say you're probably right, it's about 50-50. That look about right? 50-50?
Yeah, I'd say more like 52 and
All right.
48. Yeah.
Now I'm going to pour. Okay, I'm going to pour in a non-polar. That's where you guys know water's polar, right? Remember our bear sitting up there? This is
Water
a
is
non-polar solvent. This is non-polar. Will it mix with the water first of all?
No.
Okay. Okay. Let's see. I think you're right though. Pour some in, and you notice it sits on top of the water. It sits on top of the water. See, there's two layers. See the two layers? Now the idea is to shake this and see what those dots might do. Okay. And just keep my fingers crossed a little bit. Okay. Sometimes some of them sink and everything, or they'll stick together, and that can create some trouble. If this works out right, what we should see is that they all orient themselves in one particular way. Instead of up or down, they'll they'll flip. Yeah, they'll flip over, and you'll get most of them now. See, I didn't get 100%. Sometimes I do. Most of them have their dark side up into the cyclohexane, and the other side down in the water. And there's a reason for that. Anybody want to speculate on what that reason might be?
The electrons in the lead or something go to the stuff in this.
Well,
Take a shot.
yeah. Well, thanks for participating. It has more to do with solubility now, and the polarity of the molecules. What would mix with nonpolar solvents? But if it doesn't mix with water, it might mix with what else could it mix with?
Non-polar.
Like what? Like what is something that doesn't mix with water?
Oil.
Oil. What does
Rocks.
but what does oil mix with?
Stones.
Gasoline.
Gasoline. There's a good one. Oil and gas. That's a typical mixture for two-cycle engines. You don't put oil and water together or oil and gasoline together because they won't mix.
Yeah.
In fact, if you put oil or water in a gas tank, somebody's gas tank, that would be a nasty thing to do, and it might hurt their car. And it wouldn't start. But anyway, so my point was polar likes polar and nonpolar likes nonpolar. So what side of the 3x5 card was nonpolar?
The dark side.
The graphite side. Right. Can you wash pencil off a piece of paper with water?
Yes.
You can?
Sometimes.
Well, how do you get it off?
Well, not paper, because it's
Eraser. Right.
Rubber.
It doesn't dissolve. It doesn't dissolve in water because it's not the same polarity. So what that shows is it has a preference. It prefers the non-polar. Okay. Did I my phone just ring?
Yeah, you did.
Yeah.
But it stopped.
Okay. That works. I get tired of answering. Okay. That's basically it, guys. So we had two demos today. And we're back on track. Although it's hotter than blazes in here. I got to get that fixed.